Hi everybody. Today we're going to talk about slopes of lines. And you already have some ideas about slopes of lines, but today we're going to really cement those ideas. I'm going to write that slope formula one more time. I think of it as delta y over delta x. You may want to think about that as y sub 1 minus y sub 2 over x sub 1 minus x sub 2. But we're going to find the slope of a lot of points right here, and we'll try to relate those slopes with one another. First, it has to be for the slope of line AB. I'll take the time to write the coordinates of A and B. Negative 4, 9 for A, and B is at 12, negative 3. I have a lot of experience teaching kids about these kinds of things, and man, they get the wrong points, or they get the slope wrong. It's really important that we practice getting slope. Let's do this well. I got to put the y's on top. I'm going to choose a y coordinate 9 minus, and if I chose that y coordinate, I got to go to this y coordinate now, 9 minus negative 3. If I began with that y coordinate, then I got to begin with this x coordinate in the denominator, negative 4 minus 12. Y coordinate minus y coordinate over x coordinates minus x coordinate. And that gives me 9 plus 3 really is 12 over, and negative 4 minus 12 is a negative 16. We ought to always reduce every fraction we could, and you always should bring the negative sign, if you have one, to the numerator. So this is negative 3/4. So we have the slope of AB. And if we were to graph that line AB, it ought to look like it goes down 3/4. And we'll worry about that later. Let's look at line DF as well, please. And I'm going to get those points handy so I can work with them. One of the mistakes kids do is they'll transpose points, and you can't let that happen. D is at 9, 5, and F at 3, negative 3. That happens to be F. And give me a y coordinate 5 perhaps, minus the other y coordinate negative 3 over the, if I choose that y guy, I've got to start with this x guy first. 9 minus that x coordinate, positive 3. All these times you ought to pause that video, make those calculations, and then we'll compare our answers. But I see 5 minus the negative 3, which is really 5 plus 3. That's going to give me 8 over 9 minus 3 is going to give me a 6. So out of that I got a slope of 4/3. Now that is an interesting slope compared to this slope, as I consider the slope of line DF and compare it with the slope of line AB. Let's go further. We'll talk about that in a minute. You might be thinking about it already. I'm going to get the slope of line EC, so I got to use those 2 points. Negative 8, 1, and C at 4, negative 8. I can start with that y coordinate first if I wanted to. That'd be okay with me. Negative 8 minus, but if I start with that y coordinate, then I got to go to minus 1. And if I begin with this y guy, I got to start with that x guy. So in the denominator, that'd be 4 minus negative 8. And I got to make those calculations. And negative 8 minus 1 is a negative 9. And 4 minus a negative 8, that's really 4 plus 8. That's a positive 12. So from this, I get a negative 3/4. Which is interesting, because that was the slope of line AB. So line EC and AB have an interesting relationship. We ought to talk about it right away. Then there's this line GE that we can show amongst these other lines. Keeping this thing straight, I'm going to give it the coordinates of G, which was at 6, negative 2. And point E, we know to be at negative 8, positive 1. Pause the video, get that slope, and I'm going to do it right after you. Y coordinate negative 2 minus y coordinate 1. X coordinate positive 6 minus x coordinate negative 8. That gives me a negative 3 over a positive 14. And I can't reduce that fraction. I'm just going to leave it that way. So now I'm wondering, classify the relationships between these lines. And I hope you're thinking what I'm thinking. Look at this. Line AB and line EC, they have the same slopes. So what would we think about their graphs? And I bet you're thinking the same thing I'm thinking, that AB, that line, should be parallel with line EC. Because when lines have equal slopes, they're going to be parallel. But what about this line DF? Check its slope. I think it has an interesting relationship as well. Actually, DF has the negative reciprocal slope of lines of these two, lines AB and EC. That makes me think that line DF would be perpendicular actually to both of those lines. I'm going to write it this way. It's perpendicular to AB, and just using that symbolic logic statement for and not everybody would, but we could, I think. I think that DF is perpendicular to AB and to EC. But what about this line GE? GE doesn't have a matching slope with anybody, and nobody has a negative reciprocal slope, so GE is neither parallel nor perpendicular with any of these other lines. That makes GE be oblique. A line that is neither parallel nor perpendicular is an oblique line. O-B-L-I-Q-U-E. It is oblique with the others. It just doesn't have much relationship. It's not parallel. It's not perpendicular. Now I graphed these points, and let me show you about that. I graphed all those points, and I'm just going to show some of those lines. We talked about line AB, and line AB would look like this. We also talked about line DF. I'm going to show line DF. D's here and F's there. I'll show that line best I could. My graph's not perfect, but it's pretty close. We also talked about line EC, and here's E and here's C. Let me show that line also. And it's just me sitting at a desk drawing these lines, but I'm thinking they're looking pretty good. Let me also show that line GE. Here's G, and where's it? E's over here. It gets a little bit complicated picture, but let's take a look at it, see what we said is true. We said AB and EC were parallel. And it does look that way to me, that this line AB and this line EC are parallel. That's kind of a nice way to denote it with those arrowheads. And we also said that DF, and this is line DF, was perpendicular to AB. And I'm saying, well, that has to be a right angle right there. If lines are perpendicular, they form right angles. And it's also perpendicular to EC. Close those parentheses. And if DF is perpendicular to EC, we got a right angle right there. But what about this line GE, just knifing through here? That's not a right angle. None of those are right angles. It's not perpendicular to anybody here. And it's not parallel to anybody. Yep, it's an oblique line. Now, we're going to graph some lines here. I got to continue this axis system, and you better continue it too if you're doing this with me. So I'm going to set up an axis system and give myself a y-axis here. And I might go to, say, 7 or 8 in all directions. Now I'm ready to go. Give the slope for the line, through a point not on a line, there exists exactly one line parallel. That's a nice postulate. We ought to say it a couple times. Through a point not on a line, there exists exactly one line parallel. We're going to get the slope-intercept form of this line L. To make that, I have to make that line take the form y equals mx plus b. Really a big part of what you learn in Algebra 1 about graphing lines. And if we can put this line in that form, or this equation in that form, we'll be able to graph it quickly and easily. I think I got space to do it right here. I'm going to keep the 3y on the left-hand side. I'm going to bring that positive 2x to the other side and that negative 15 to the other side. When I do that, it's going to become a negative 2x. When I bring the negative 15 to the other side, it becomes a positive 15. But I want to get 1y by itself, so I got to get rid of that multiplication with 3, so I'll divide both sides of this equation by 3. And then I'll have the equation in the proper form so I could graph it. 1y is equal to negative 2/3 x plus 5. Just 15 divided by 3 giving me that 5. So here's my slope-intercept form of line, what do we call on this line? Line L. There's its equation. Let's graph it. So if I were going to graph that line, I'll do what I do to graph any line anytime. I'll go to the y-intercept if it's available, and there we have it at 5. Up 1, 2, 3, 4, 5. And from there I'm going to follow the slope, which tells me to go down 2 and over 3. I'll do that, down 2 and over a few. Or I could go down 4 and over 6. That would be pretty good too. That'd be something about there, I think. Notice this point should appear collinear. Let me get a ruler on and get a look at that. Best I can do it, I'm saying there's line L. But remember, we're going to talk about a line through a point, not on a line. There exists one line parallel. I'm supposed to show this point P, which is at -6, -2. Left 6, 4, 5, 6, and down 2. And our job is to find the equation of the line that goes through that point P, that's parallel to this line L. And I made this little note. Slope, I want to make it the slope of a parallel. And what you got to remember is when lines are parallel, they'll have equal slopes. So what's the slope of this line? -2/3. The slope of any parallel line would also be -2/3. And we're going to choose to go through this point P at -6, -2. And the tool that we will use in this class for the next couple of weeks when we're finding equations of lines will be the slope-intercept method. The point-slope method. The slope-intercept method to graph them, but the point-slope method to find the equation. Y minus y sub 1 equals m times x minus x sub 1. And we will make a substitution here and here and here. We'll choose this for the x-coordinate, that for the y-coordinate, and that for the slope, and make those substitutions and see what comes. Y minus a -2. And for m, I should use that slope -2/3 times x minus a -6. I think when we get a little better at this, we're going to drop those two minus signs and go right to the plus or positive in that step. But right now, let me just be as careful as I can be. I get y plus 2 on this left-hand side is equal to -2/3 times x plus 6. Now I'm going to multiply through those parentheses, and I get y plus 2 still is equal to -2/3 x. If I multiply that -2/3 times 6, that'll be a -12/3. And a -12/3 would be a -4. As I isolate the y guy in this equation, I got to get rid of that -2, and that would become y equals -2/3 x. I'm subtracting 2 from both sides, and a -4 minus 2 would be a -6. So I'm thinking that's the equation of the line that should be parallel. Let's graph it and see if it looks like it is. Now, my graph isn't perfect, but it should be pretty close. This thing has a y-intercept of -6, down 1, 2, 3, 4, 5, 6, about here, I guess. From there, I follow the slope down 2 and over 3, down 1, 2 and over 1, 2, 3, something like that. These 2 points determine that line, and I'm looking like P is going to be on that line as well. Do my best to show it. And I think you'd have to accept that these lines look reasonably parallel. Not perfect, but I'll say that those lines are parallel with one another. So it does go through point P, and it is parallel. That's a nice little exercise. The last one on this page, really kind of a nice question, is we're going to see what we'll begin with a postulate. Through a point, not on a line, there exists exactly one perpendicular. We're going to be working with a perpendicular right here, and probably going to be showing a graph of it too, so I'm going to fix up an axis system. I don't got to go very far on that axis. Remember, like 7 or 8 in all directions. 2, 3, 4, 5, 6, 7, 8. Let you get caught up. 1, 2, 3, 4, 5, 6, 7, 8. If that's not enough, we'll just have to go off the graph a little bit. 4, 5, 6, 7, 8. First things first, I got to put this into the proper form. That takes a step. I'll leave the y guy on the left-hand side and bring the 21 to the other side, and that would be 3y equals 6x minus 21. But as we isolate the y guys, because I want just y equals mx plus b, I want to have this formula. So I'm going to divide through by 3, dividing both sides by 3, yielding y equals, and 6x over 3 is just really 2x, minus 21 over 3, just 7. So now we've got a pretty good look at the equation of that line. I think I'm ready to graph it if I needed to. It has a y-intercept of -7. I think we went down about that far, 4, 5, 6, 7, there, about there. From there I'll follow the slope up 2 and over 1. I guess if I went up 7, I have to go over about 3.5, something like that. But I'm going to show that line the best I could. Something about like that. And the name of that line, I think that was line M. So I'm going to put an M by it, because we may want to talk about it later. Now this M talks about the slope, and I specifically want the slope of a perpendicular here. So you want to be thinking about that with me. We're also supposed to show the point Z, which is at -6, comma +6. I'll do that now. Left 1, 2, 3, 4, 5, 6, and up 6. That'd be a right around here, I guess, something like that. There's my point Z. And it's a little bit crowded on this page, but I think we can make it work. We're supposed to show the equation of the line that goes through Z that is perpendicular to this line M. What would be the slope of that perpendicular? So you think to yourself, I would think to myself, well, what would be the slope of a line that's parallel first? And parallel lines have equal slopes, and the slope of this line is just 2. I would report that as 2 over 1. And then when somebody asked me about the slope of the perpendicular, I said, well, it's the negative reciprocal of this one. That'd have to be a -1/2. There's my perpendicular slope. And we need to go through the point Z, which is at -6, +6. And we got one tool that gives us the equation of a line. Let's use it. Y minus y sub 1 equals M times x minus x sub 1. Let's make those substitutions in this place, and that place. In the place of the y coordinate of the point we want to go through, that'll have to be y minus 6 equals, in the place of M, the slope of this perpendicular line, which has to be a -1/2, times x minus the x coordinate of the point we've chosen, and that's a -6. X minus a -6, allow me to call that x plus 6. Now, I should multiply through those parentheses. I'll keep this y minus 6 for now. Multiply through there, and I get a -1/2 x. And a -1/2 over +6 would be a -3. But let's isolate y completely. Let's add 6 to both sides of that equation. We have y equals -1/2 x. Adding 6 to this -3, as I add 6 to both sides of this equation, gives me a +3. So there's the equation of the line. That should go through point Z, and it should appear perpendicular to this one. Let's roll and see if it goes that way. How do you graph that line? Well, like you graph every other line. You go to the y-intercept first. So let's march up 3 places on that y-axis, right about there. From there we can follow the slope down 1 and over 2. Down 1 over a couple. Something about like that. I could probably go down 3 and over 6. That would be the same idea. And then I think these points should appear collinear. I'm going to show that line the best I could. Through the y-intercept, through the point that we knew it had to go through, and actually through its x-intercept as well. And there we have it. There's line, do I know the name of this line? It's the line that goes through point Z, and it is supposed to be perpendicular to line M. I didn't name it, but that's okay with me. I'm saying that those lines appear perpendicular. Now, let me show you an interesting little skill that would be important. This problem is done, except I wonder, where do those two lines intersect each other? We want to find the coordinate of that place right there where those two lines intersect each other. What is it you do with the equations of those lines when you'd like to see where they intersect? That's important. So pause the video, think about that, but I'm going to tell you about it right away. When you would like to know where two curves or two lines or two equations intersect, you're going to set them equal to each other. You have to have them in this form where y equals this and y equals that, and then we can set them equal to each other. Watch how that'll look. I'm going to say that since y is equal to 2x minus 7, then 2x minus 7 must equal what y equals here, -1/2 x plus 3. Let's just solve that little equation. And if you're going to do this, you probably add 1/2 x to both sides. That's a good thing to do. If you did add 1/2 x to both sides, you'd have 2 and 1/2 x minus 7 is equal to 3. Let's isolate those x's. I have to add 7 to both sides, and that would give you 2.5 x. is equal to 10. And you might see this answer coming. It's apparent to me what x would be, but there's a little system that you go through, an algorithm that you go through. We should make this an improper fraction. You do that by 1. 2 times 2 is 4, plus that 1 is 5. 5 over 2x is equal to 10. These equations really are the same equation. I want to get x by itself. To get x by itself, I have to multiply by the reciprocal of its coefficients. That 2.5 is really 5 halves. The reciprocal of 5 halves is 2 over 5. I'm going to multiply this side by 2 over 5. That forces me to multiply this side also by 2 over 5. As I do that, what good has this done? Well, now look, I got 10 over 10. And 10 over 10 is just the same as 1, so I got 1x, which is what I wanted. And on the right-hand side, I'm thinking of that 10 being 10 over 1. Multiply straight across the top, which would give me 20. Straight across the bottom, which gives me a 5. So I got 20 divided by 5. That's got to be 4. So this convinces me that going back to this picture, that the x-coordinate of this place must have been 4. Because when we set the equations equal to each other, we get that value. But here's another nice thought. Consider this. I'm going to find the y-coordinate on that point. And you can guess at it, but let's do it correctly. One of the equations was y equals 2x minus 7. And we know that x was equal to 4. So that should be y equals 2 times 4 minus 7. That'd be y is equal to 8 minus 7. That'd be y is equal to 1. That fits for me. The other equation we found was y equal to negative 1/2 x plus 3. What would happen if I put that 4 into that equation? Well, let's walk down that path and see. Y equals negative 1/2 times, he's letting x be 4 because he knows the x-coordinate where those lines cross each other was 4, plus 3. Y equals, and a negative 1/2 of 4 is a negative 2, plus 3. Yep, we get that same amount. Y is equal to 1. So, by gosh or by golly, y is equal to 1 and x is equal to 4, and that's the coordinate of that place right there, was at 4, 1. This brings an interesting thought to my mind, and I'd like to show it to you. What if we were to use that thought and try to figure out where these two lines cross each other here? And I know what you're thinking, I hope I do. You're saying, well, those lines don't ever cross each other. I said, well, what would happen if we set the equations equal to each other? They have these two equations, those two parallel lines. Let's just take a walk down that path and see what happens. I'm going to set those two equations equal to each other. I'm going to see where these two lines cross each other. Negative 2/3 x plus 5 is supposed to be equal in this case to negative 2/3 x minus 6. And the value of x that makes this sentence true, well, that'll be the x-coordinate where those two lines cross each other. Well, let's see about that. Now I got negative 2/3 x on both sides. I guess I'll add 2/3 x to both sides. I'll bring this to the other side. But actually, when I do that, the 2/3 x are going to cancel, aren't they? So what are you left with is just 5 is equal to negative 6. So I ask you, when is 5 equal to negative 6? And that answer is never. So I ask you again, well, where do these two lines cross each other?